Hi everyone, welcome to iQuanta. Welcome to the iQuanta Quant 250 series for IPMAT most expected questions. I hope you have done the previous ones. This is a very important series, okay. A lot of questions from this series can come in the exam, not the exact questions but with slightly changed data, okay. And since just a week is remaining for IPMAT Indore, I hope you guys are attending the marathons that we are conducting on our channel. So in the morning 9 to 12 we have verbal ability marathon, in the evening 6 to 8:30 we have the quant marathon, and right after Indore we will also be starting with IPMAT Rohtak specific marathons. Once Rohtak is over we will be starting with jipmat specific marathons, okay. So this is one such channel that you can rely upon, and if you want the notifications of all the events that we are doing on YouTube, subscribe to the channel, okay, because the moment we go live you will get a notification and you will not miss any session, okay. We already had done somewhere around 143 questions in the series. I gave couple of questions to you as homework. We will start with this one, okay, an easy modulus question. If mod a minus 5 is equal to 5 and mod 2b minus 10 is 8, find the difference between maximum and minimum value of ab. Now even though this is not IPMAT Indore level, okay, it's very easy, but still I mean I am making you guys solve some easy questions as well in between, so that the thing is many of you might not be knowing the basics, okay. So with easy questions you do the basics as well. So mod a minus 5 is 5, that means what happens, a minus 5, this is something whose value is 5, so that means this can be plus 5 or this can be minus 5, isn't it? So this implies that a will be 10 and this means that a will be 0, okay. Two values are possible for a. Similarly 2b minus 10, 2b minus 10 whose mod value is 8, so it can be plus 8, or we can also have 2b minus 10, the thing inside modulus is minus 8, because if you take mod of 8 or minus 8 both will be 8. If you take mod of this 5 or minus 5, we will get 5, okay. So solve here, here we will get b equals to 18 by 2, that is 9, and here we will get 2, b will be 1. The question basically wants us to find out the difference between maximum and minimum possible value of ab. So maximum possible value of ab is when you multiply values of a and b. So ab have two values possible, okay, four values possible, 10 into 9, 10 into 1, 0 into 9, 0 into 1. So max value of ab, it will be 10 into 9, 90, and the minimum value of ab, it will be obviously 0 into anything, okay. So 0, so 9 minus 0, we needed a difference, that is 9, okay. That's our answer. Easy question, okay. Now we have this one, x minus 3 square equal to 2 mod x minus 3 plus 3, find the value of a minus b, where a is the maximum value of x and b is the minimum value of x, okay. So x minus 3 square is written, you know that square is positive, so this can also be written as mod x minus 3 square. This can be brought here, so minus 2 times mod x minus 3, this plus 3 can be brought here, equal to 0. If you take this mod x minus 3 as t, if you take mod x minus 3 equal to t, this can further be written as t square minus 2t minus 3 equal to 0. We will factorize this, t minus 3, t plus 1, that is equals to 0, t can be 3 or t can be minus 1. T is a mod quantity, mod x minus t. Can t equal to minus 1 be ever possible? No. Value of some modulus, it can never be negative minus 1, okay. So we will remove this. That means t equal to x minus 3 is the only value possible. So x minus 3 mod, that is equal to 3. So if this is equal to 3, that means x minus 3 thing inside the modulus can be plus 3 or thing inside the modulus can be minus 3. So this means that x will be 6 and this means that x will be 0. What is the difference between the maximum and minimum values? I have got two values of x, maximum value is 6, minimum is 0. 6 minus 0, that is what we wanted, answer will be 6. This difference only, isn't it? Where a is the maximum value, b is the minimum value of x. I hope this question is also clear. Now we have this question, okay, if x is a multiple of 2, then find the possible values of x that satisfy this. So there are multiple inequalities, multiple modulus inequalities to compare over here. So first of all, let us take these two into account, okay. Mod x minus 10, this simply means that this is the distance between some value of x and 10, right? Because as I told you that mod x minus a basically means that this is the distance between some point a and the value of x that we are looking for, okay. So mod x minus 10 will be the distance between some value of x and 10, this is the distance between x and 70. So what are the critical points? 10 and 70, 10 here, 70 here. What happens? I want such an x, we are looking at this part, okay. We are looking at this part first and I have put the critical points. I want the distance of x, x will be somewhere on this line, isn't it, and from that x will measure the distance of 10 and 70. So, distance of x from 10 will be lesser than the distance of x from 70. Now, if you come exactly in between 70 and 10, so 70 plus 70 minus 10, that is 70, 80, so exactly between 10 and 70 we have 40, right, 10 plus 70 by 2, that is 40. So, if x is equal to 40, what happens? The distance of x from 10 is also 30, the distance of x from 70, that is also 30. We want the distance of this x to be less from 10 and more from 70. Less from 10, that means this x should be towards 10, it should be close to 10, then close to 70. So, when we come exactly between 10 and 70, again look at this, 10 and 70 are my critical points of these moduluses. Okay, what is the critical point in a modulus? The value of x at which the value inside the modulus becomes 0. So, exactly between 10 and 70 we have 40. In fact, let me just erase it and write it clearly. I'll just keep 10 70 a little bit far, okay. So, this is 10, this is 70, this is 10, this is 70. I want an x which should be closer to 10 than from 70, because from 70 the distance of x should be greater. So, exactly between 10 and 70 we have 40, right, exactly between 10 and 70 we have 40, 10 plus 70 by 2, 40. So, this 40 right now is at a distance 30 from 10 as well, at a distance of 30 from 70 as well. So, if my x is 40, I am actually equally distant from 10 and 70 both, but I want my x to be closer towards 10, that means towards 10 then 70. So, obviously x should be towards here, isn't it? Now, this is what I need, isn't it? So, obviously my x will lie less than 40, it should be less than 40, it should not go 40, because at 40 it is equal, okay, at equal distance from 10 and 70. So, my x should be less than 40, and it can be anywhere around this, okay, it can be if x is somewhere around here, okay, suppose x is on this side of 10. So, obviously the distance of x from 10 is this, while the distance of x from 70 is obviously greater. So, all values of x are satisfying it. So, can I say that x should be less than 40? In that case, this is being satisfied, right? So, this is what I get from here. What about these two? Okay, I have to include this as well. So, here I have two critical points, those are 30 and 70, isn't it? So, 30 is this, 70 is this. I want my x to be closer to 70 than 30. So, exactly between 70 30 we have 50. If this is my x, then my x is equally distant, equally far from 30 as well, 70 as well, but I want my x to be closer to 70, because distance of x from 70 is less than distance of x from 30. So, obviously x should lie towards 70, from the half towards 70. So, obviously greater than 50, that means if x is greater than 50, then 100% what is going to happen? Then 100% if x is here, suppose here, then the distance of x from 70 is only this much, while the distance of x from 30 is this much. If x is somewhere around here, the distance of x from 70 is just this much, while its distance from 30 is this much. So, x should be greater than 50, isn't it? Now, what do you see here? There are two situations which we had to satisfy. First, these two inequalities, then these two inequalities. For these two, I got this as the answer. For these two, I got this as the answer. Now, all these three are simultaneous inequalities, right? This is a simultaneous inequality, this is a simultaneous inequality. So, we have to combine the solutions in such a case, okay. So, this says that if I have to combine the solution, what do these both solutions say? It says that my x should be less than 40, so x should lie less than 40 towards here, while it says that x should be greater than 50, so x should lie here. Is there any common region between these two? There is nothing common. Will there be any value of x which is greater than 50 as well, but less than 40 as well? It is not possible. So, there will be 0 such values of x, right? There will be no such value of x possible for which this statement will be true. So, I hope this question is clear. We have the replica of this question here, okay. The number of integers n that satisfy the inequality is mod of n minus 60, okay, less than mod of n minus 100, and then less than mod of n minus 20 is, okay. So, we'll compare these two first. My critical points are 60 and 100. Okay, 60 and 100. My n should be such, this is distance of n from 60, distance of n from 100, distance of n from 20. In this, I want my n towards 60. I mean closer to 60, then closer to 100, isn't it? Because distance from 100 is more. So, what will we do? Exactly between 10 and 60 we have 80, isn't it? Exactly between 10 and 60 we have 80. That means if my n is 80, its distance from 60 as well as from 100 is equal. But I want my n to be closer to 60. So, I will take it towards this. That means less than 80, yes or no? So, n should be less than 80 in this case. While if you compare these two parts, then my two critical points are 20 and 100. 20 and 100, right? I want the distance of n, I mean I want n to be closer to 100 than n is closer to 20. Exactly between 10 and 20 we have 60. That means if n is 60, it is 40 distance from 20, 40 distance from 100. I want my n to be closer towards 100 because this distance from 20 is less than, and this is greater than the distance from 100. So, n should lie above 60, isn't it? So, n should be greater than 60. What do I want? I want to combine these two solutions. So, this says that n should be greater than 60. So, this is 60, greater than 60, that means this region. While the other solution says n should be less than 80. So, that means where is 80? See, since you are combining the solutions, assume that if 60 is here, 60 is here, 80 will be somewhere around here, isn't it? So, this is less than 80, that means you are coming less than 80. So, that means which is the common region here between 60 to 80, but we will not include 60 and 80, okay. Greater than 60, that means we will go to integer values of n that are greater than 60, but integer values of those n which are less than 80. So, we will start with 61, 61 is greater than 60, 62, and we have to stay less than 80, less than 80, that means last value is 79. 61 to 79 we have total how many values? 19 integral values. So, 19 values will be my answer. There will be 19 such integral values of n. I hope this is clear. This was a very good question, okay. I think this question also came in CAT, okay, a few years back. I hope the solution is clear to you. Now, let us try this question. Find the minimum value of y equals to mod x plus 3 plus mod x minus 5 plus mod x minus 7. So, there are three modulus terms which are being added. Modulus terms, that means this is 0 or more, 0 or more, 0 or more, because I mean the least value that a modulus term can take is 0, right? It can never be negative. So, when multiple modulus are being added, so the minimum value is at when is at median critical point, okay, median critical point. We have done, I have already explained you why the minimum lies at median critical point in the previous class, okay, previous session of this 250 series. So, first of all you have to find out the critical point. Critical point are the points at which the modulus individually becomes 0. This becomes 0 at x equal to minus 3, this becomes 0 at x equal to 5, this becomes at 7. So, minus 3, 5, 7. You have to, whenever you have to find out the median, you have to arrange the critical points in increasing order, okay. So, when we have odd number of values, we have a single median, that is 5. You push back this 5 into the equation that you have been given. So, that will be 5 plus 3 plus 5 minus 5 plus mod of 5 minus 7. 5 plus 3 is 8, 5 minus 5 is 0, 5 minus 7 is minus 2 ka mod is 2, 8 plus 2, 10. This will be the minimum value of this particular mod. I hope it is clear. Such questions have repeatedly come in IPMAT earlier as well. So, I think nobody should be losing any marks here. What about this? If y is equal to mod x minus 5 plus mod x minus 6 plus mod x minus 7, okay, there are so many moduluses till x minus 24. So, x minus 5, x minus 6, x minus 7, 8, 9 till 24. Then for how many real values of x does y attain its minimum possible value? So, again lot of modulus terms are being added there. I mean the minimum value of this entire equation will be at median critical point. So, we are starting with 5, 6, 7, 8 and we are going till 24. I have these many critical points. How many critical points do I have in total? If there are odd number of critical points, there will be a single median. If there are what? Multiple. But if there are even number of critical points, then there are two medians, right? But if there are even number of total critical points, then there will be two medians, right? So, let us count these values. See, whenever you have a series in which difference is 1, this is a series having difference of 1, and if you want to find out total number of terms, that will be equal to last term minus first term plus 1. So, 24 minus 5, 19, 19 plus 1, 20. That means there are 20 terms in this series. So 20 terms, that means even number of terms, even number of terms means there will be 2 medians. Okay. So always remember there will be 2 medians. So in fact, let me just explain it like this. Okay. There will be 2 medians. There are 20 terms, right? So 20, that means you take 9 here, some 9 values towards this side, 9 values towards this side. So start from 5, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13, this will be 14, this will be 15, this will be 16. 16 to 24 will be having 9 critical points here. 13 and starting with 5, 5 to 13 will have critical points here. And in between, exactly in between, we'll have 2 critical points, 14 and 15. So now the question is asking us, for how many real values of x, not integral values, okay, real values of x does y attain its minimum possible value, okay. So let me tell you one thing, okay, suppose, let's see this with an easier example, okay. Suppose, for example, this is for example, if I give you a question like this, x minus 1 plus x minus 5, okay, clear, y equals to mod x minus 1 plus mod x minus 5. So what is going to happen? I am going to find out its minimum value. Minimum value will occur at critical points, right? So we have 2 critical points, 1, 5. There are even number of critical points, so both are median. Both are median. So now what happens in this case? Either you take 1 plus 5 by 2, that is 6 by 2, that means 3. If you put x equal to 3, what is the value that you will get? When there are even critical points, there are 2 medians, and what is the actual median in that case? The sum of both the medians, average of both the medians, that is 3. If you put x equal to 3 here, 3 minus 1 is 2 plus 3 minus 5 is 2, that means the maximum value of this will be, minimum value of this will be 4, right? Minimum value of this will be 4. But if you pick up any real value which is between 1 to 5, for now I just took one single value of median, that is 3, okay. But if I take any real value, any value which is between 1 and 5, say I take 2.5, that means pushing 2.5 into this should again give me 4 only. And if pushing any value between 2 median critical points give me the same value 4, that means I can take any real value between this 1 and 5. So let me take any real value between 1 and 5. This happens only when there are even critical points, okay. So even critical points, there are 2 medians. Between these 2 median critical points, you can take any real value and let's push it here. So suppose I am putting x equal to 2.5. So 2.5 minus 1 is 1.5 plus 2.5 minus 5, that is 2.5. What is the sum that you are getting? You are getting again 4. 4 is the minimum here, 4 is the minimum here. You got the minimum when you got this single median critical point, and also when you take any random value. Now just take any other value as well. Let us test this at x equal to say 3.7. 3.7 is any value between 1 and 5. If I put 3.7 into this, if I again get what, 4, that means I can find out the minimum value of such equations where multiple modulus are being added at any real value between the 2 median critical points. So put 3.7, 3.7 minus 1 is 2.7 and 3.7 minus 5 is minus 1.3. Minus 1.3 ka mod is 1.3, 2.7 plus 1.3 is 4. That means if you pick up any real value between these 2 median critical points, you will always get the minimum. Can I just replicate it here in this question? I have 2 median critical points. That means if I take any real value between 14 and 15, and if I push it back into this multiple modulus being added, I'll again get the minimum value only. So how many real values do we have between 14 and 15? We have infinite real values between 14 and 15, and if I put any of those values in the equation, I'll get my minimum value only. So a lot of students, what they do is they simply calculate the median of 14 and 15, which is like 29 by 2, and then they think that okay, there will be only one value of x which will give the minimum, but there will be infinite values, okay. I hope the concept is clear. If you are not able to understand, please listen to patiently what I said, okay. Now let us try to solve this question. Find the values of x if mod x minus 4 plus mod x minus 10 equal to 17, okay. That means there are 2 critical points here, yes or no, which are 4 and 10. And when you say mod x minus 4, that is the distance between x and 4. When you say mod x minus 10, that is the distance between x and 10, okay. You want the sum of distances between x and 4 and x and 10 equal to 17. If your x is here, suppose your x is here, this is the distance from x to 4, distance from x to 10. And if you add these two distances, is the sum of distances ever going to become 17? No, because the distance between x, if x is here, this is the distance between x and 4, this is the distance between x and 10. The maximum distance that you can have between 4 and 10, that will be 6. So, is there any value of x here which can make the total distance equal to 17? No, there is no solution here. The maximum distance between 4 and 10 is 6. So, there will be no such value of x here. What about this region? Okay. This means you are going ahead of 10. If you take any value ahead of 10, that means say 12. So, 12 minus 4 is 8. So, if you put x equal to 12 here, so 12 minus 4, that is mod of 8 plus mod of 12 minus 10. Okay. So, mod of 12 minus 10 is what? 2. So, mod 8 plus mod 2. So, that means putting any value which is more than 10 will make the quantity inside modulus positive, right. So, this mod will open with positive, this will open with positive. What will I get? X minus 4, when mods open with positive, when there is a positive quantity inside mod, x greater than or equal to 0, mod opens simply like x. But if the quantity inside mod x is less than 0, then in that case mod opens with negative of x. So, both the quantities, if you put any value of x which is greater than 10, if you put any value inside the modulus, both modulus are going to open with positive. So, x minus 4 plus x minus 10 is 2x minus 14. And the sum has to be the sum of distances, isn't it? The sum of distances has to be 17. This is what it means. Okay. So, 2x will be equal to 31 and x will be equal to 31 by 2, 15.5. There will be one value of x here. Okay. If you go below 4, that means put any value of x which is below 4, say 0. Okay. If you put 0 here, 0 minus 4 is negative inside modulus, 0 minus 10 is negative, minus 10 inside modulus. Both if you have negative quantity inside modulus open with negative x. So, this opens with negative minus x minus 4 and minus x minus 10. So, what happens here? We get minus 2x and plus 14. The sum of distances should be equal to 17. What will we get? Minus 2x equal to 3x will be minus 1.5. So, there is one value of x here which is minus 1.5, but here the range was less than 4. Is this value less than 4 that we are getting? Yes. If this value is not less than 4, we will discard it. Okay. Here the value was supposed to be greater than 10 because we were at region greater than 10. Is this value of x that you have got is greater than 10? Yes. So, there will be two values of x. Okay. Minus 1.5 and 15.5, at which this particular equation will have solution. I hope you can do this as well. I think it's nothing but just a replica of this. Okay. There is a slight change of plus minus 10 over here. In fact, let us do it. You are looking for the values of x if distance between these 2 points is 17. So, what are the critical points here? One critical point is minus 10, another critical point is 4. If you take x here, so this is the distance between x and 10, this is the distance between x and 4. What is the distance between minus 10 and 4? It is 14. So, will the sum of distances be ever equal to 17? No, there will be no value here. And now again, above 4, suppose you take a value which is above 4, say 5. This is positive, make a positive equation, put equal to 17, you will get the value of x. But after getting the value, you have to check if that value is greater than 4. If it is greater than 4, then only you will accept it. Okay, otherwise you will not accept it. And similarly, you take the region less than 10. So, less than 10, put any value, say minus 12. This will be opening with negative, this will be opening with negative, negative. There will be an equation formed, right? And that has to be taken equal to 17. Whatever is the value of x, if it is less than minus 10, then you will accept it, otherwise you will not accept it. I hope you can do this question by yourself. Okay, this is an easy one. Okay. Now we have this question. Okay, find the values of x if the sum of distance of x from 2, sum of distance from x to 10. So, there are two critical points 2, 10. So, sum of distances of x from 2 and 10 has to be greater than 30. Okay. Can your x lie here? Because this is the distance between x and 2, this is the distance between x and 10. The distance between 2 and 10 is 8. So, can it ever be equal to 30? This is wrong, right? There will be no value here, no value of x here between 2 and 10. Above 10 again, above 10, that means what will you do? You will put any value of x which is greater than 10, say 12. So, this is positive, equation will be formed greater than 30. Whatever value of x you will get here, if it is greater than 10, you will accept it, otherwise you will ignore it. Then again, x less than 2, says 0. This is negative. Both will open with negative, greater than 30. Equation will be formed, you will get a value of x. Only and only if it is less than 2, you will accept it, otherwise you will discard it. So, that is it. Okay. I hope this question is clear. Similarly, you can do this as well. Okay. This says find the values of x if distance between x is the mod x minus 2 mod x minus 10 इनका sum should be less than 30. So you can do it, put critical points and check in between first and then check on the other two sides. You only accept values of x if the values lie within that range, okay. So suppose there were three ranges here, 2, 10. You took your x between 2 and you took your x between 2 and 10. So if there is some value here, you will only accept it if it lies between these 2 points. There will be an equation formed of this modulus after opening with positive or negative here. If the value is greater than 10, then only you will accept it, otherwise you will ignore that value, and similarly less than 2, okay. I hope this is clear. I hope you can do this as well, right? Nothing but just plus minus of the equations, okay. Make two critical points 2 and 10. This also you can do, right? Find the minimum value of this. There are two critical points, okay, 4 and 10. So at both the minimum value will lie, isn't it? In fact, we have to find out the minimum value of sum of distances of x and 4, x and 10. So this is 4, okay, this is 10. Minimum distance, suppose you take your x here, will the sum of distances be minimum? No, because the distance of x from 10 is this, distance of x from 4 is this. This is a huge distance. If you take your x here, distance from 4 is this, distance from 10 is this. Sum of these two distances will be huge. But if your x lies here somewhere in between, this is a very small distance between x and 4, between x and 10. Sum of these two values will give us the minimum. So you take any value of x which is between 4 and 10, say 5, and put it here. So that also connects to the concept that I told you, that there are two critical points 4 and 10. There are even critical points. You take any value between these two critical points, you will always get the same middle value, okay. So suppose you take 5 or 6 or 7, 8, 9, whatever you want to take, you will get the same value, same minimum value. So what will be the answer here? It will be 14 only, obviously, because sum of these two, okay, sum of distances, right, between 4 and 10, not 14, between 4 and 10 we have 6. So let us even test it. Say I pick up any value of x which is between 4 and 10, the two critical points, say 5. If I put 5 here, 5 minus 4 is 1, 5 minus 10 is minus 5, minus 5 ka 5 is 6, yes or no? So minimum will be 6, okay, answer to this question will be 6. I hope it is clear. Now let us try to solve this question. If the minimum value of mod x minus a plus mod x minus a equal to 6, find the minimum possible values of a. Minimum possible value, that means definitely this is sum of two mods, okay. Critical point is a, critical point is 8. We know that critical point is 8, but you are not sure about a. A can be less than 8, a can be more than 8. Suppose a is 2, so it will be on this side of 8. Suppose a is 10, so it will be on this side of 8, right? But sum of distances, this is a distance, this is a distance, sum is equal to 6, okay. Find the possible values of a. Now suppose when I give you, suppose there is a question, x minus 3 and x minus say 6, and I am asking you to find out the minimum value of this. What do you actually do? You make two critical points 3, 6, and x can be on this side, this side, this side. But when do you get the minimum? When x is between these two, because this is the distance from 3 of x, this is the distance of x from 6, and their sum is minimum when x is between 3 and 6. So that means here also what we will do, this a can be here, a can be here, but minimum will occur when sum of this distance, if x is between a and 8, if x is between a and 8. So x can be here, x can be here, isn't it? So this is basically what? The distance between a and 8, isn't it? So you have to take your x in such a way that the maximum distance you can go from 8 is 6, okay. So if you go 6 that side, you get 14. If you go 6 this side, you get 2, isn't it? So what are the possible values of a? Those are 2 and 14. And you can even check this. You can take a equals to 2, then what happens? The distance between 2 and 8, x will lie here, it will be 6 only. And if you take 14, a is 14, forget this part now, a is 14. So what is the minimum value of mod x minus 8, mod x minus 14? That is equal to 6 only, okay. I hope that is clear, okay. So this is what you have to do in such questions, okay. Otherwise you can take a here once and then maybe form equations, but that will be a long way, okay. I hope this part is clear to you. When do we get minimum of two moduluses? When they are being added. These are the critical points. Obviously when x is here, the distance from 3, then distance from 6 is more. If x is here, distance with 3, distance with 6 is more. But x is between 3 and 6, then the sum of distances of x from 3 and 6 is minimum, So that is the reason we have done this. Okay, it always lies between the two critical points. So between two critical points, between two critical points. Okay. So from 8 we went 6 this side, 6 that side, we got 2 and 14, that's our answer. Now let us solve this question. Find the largest real value of a for which mod x plus a plus mod x minus 1 equal to 3 has infinite solutions for x. I hope you remember there are two critical points here, 1 and minus a. Okay. So 1, okay, and minus a can be here as well, minus a can be here as well. Now you must be thinking, why have I put minus a here? See, if a is, if this is mod x minus 5, mod x minus 5, that means critical point is 5, 5 will be on this side of 1. If this a is 1, so x plus 1, that means critical point is minus 1, minus 1 will be on this side of 1, right? You have been seeing for a while that if I have to calculate, suppose this is again simple question or like this. Suppose this is my question and I am finding out the minimum value, okay. So then what happens in this case? I know that 1 and 5 are my critical points, 1 and 5, and when do I get the minimum value? When x is between 1 and 5, yes or no? That is why the distance from 1 and from 5 is the minimum. So that means I am actually counting the distance between 1 and 5 and that should be equal to some given value. So here also can I say that this is a distance, this is a distance, sum of those distances is 3. So distance between 1 and minus a should be equal to 3. So distance is always taken in mod between 1 and minus a. How is that written? 1 and minus a. The distance has to be 3. Can I say it like this? The distance between 1 and minus a has to be 3, and that can be represented like this. Okay. So this becomes mod of a plus 1, that is equal to 3. So that means a plus 1 can be 3 or a plus 1 can be minus 3. So a will be minus 4 or a will be 2, right? You can even verify this. A is minus 4. So if a is minus 4 here, that means x minus 4 means critical point is 4, okay, and we have 1 here, so 1, this is 1. What is the distance? If x is here, what is the distance of x from 1, x from 4? Sum of distances 1 to 4 distance is 3. In fact, if you put a equals to 2, so that means mod of x plus 2, that means critical point is minus 2. So critical point is minus 2 and then critical point here is 1. What is the distance between 1 and minus 2? It is 3 only. In the right hand side we have 3 only. Got it? So this is how you can solve this question. Okay. We wanted to look for the largest value of a. So that will be 2 only. Okay. I hope this is clear. This is a very good question. Okay. Then we have this, find the minimum value of this. There are what? 1, 2, 3, 4, 5 critical points. Which is the middle one? 1, 2, 3. At x equal to 50, this is the critical point, right? Put x equal to 50 in this, you will get your answer. Okay, if there are odd number of critical points, 10, 30, 50, 80, 90, odd number of critical points, minimum will be at median critical point, that is 50. Okay, we have to find out minimum value of this 10, 30, 40, 50, 80, 90. Now here there are infinite such values of x. Why? Because how many critical points do we have? 1, 2, 3, 4, 5, 6. So these two will be the median ones, 40 and 50. So at 40, at 50 or any value of x between 40 to 50, you will get minimum value. So put any value of x between 40 50, say take the middle value, that is 45. Put 45 into this, x equal to 45 into this, you will get your answer. Okay, this is also very easy. Then we have this question, you know how to find out the minimum value. Find out the critical points will be minus 3, 5 and 7. So median critical point is 5, put 5 into this, you will get the answer. Let's solve this question now. Find the ordered pair solutions x, y for this equal to 12 if x and y are distinct integers. Here we have to make sure that they are distinct. Mod x plus mod y plus 4, this we are not sure about the minimum maximum value, but this we know about that. The minimum value of mod y plus 4 is going to be, mod y will be minimum 0, 0 plus 4, 4. So this can be minimum 4 and just see the product of these two is equal to 12. So definitely 12 can be broken like 1 into 12, 3 into 4, 2 into 6. So this number can only take values 4 or more. So 2 into 6, okay. So this will be 3 into 4, 2 into 6, this will be 12 into 1, right. So what happens here? If mod y plus 4 is taken equal to 4, we will get some values of y. So mod y plus 4 is taken equal to 4, that means mod y is 0. If mod y is 0, that means y is 0. Clear? If mod y is 0, 0 plus 4, 4, 4 cancels 12, we get 3 here. So 3 will be equal to mod x minus 4, right? So mod x will be equal to 7. That means x will be plus minus 7. So what will be the pairs formed? Plus minus 7 comma 0. This is one pair formed. Similarly, this is done. So then you will take mod y plus 4 equal to 6. So say you take mod y plus 4 equal to 6. Mod y will be 2. Y will be plus minus 2. If this is 6, this part is 6, this has to be 2. So mod x minus 4 is 2, mod x is 6, x will be plus minus 6. So plus minus 6 plus minus 2, so plus minus 6 plus minus 2. There are 4 values here, okay, 6 plus 2, 6 minus 2 minus 6 plus 2 minus 6 minus 2. And similarly 2 pair of values here, plus 7 0 minus 7 0. So we got 2 solutions here, we got 4 here, okay. I hope you understand 4. Why 4? Because there are 2 values of x here, 2 values of y here. So plus 6 plus 2 plus 6 minus 2 minus 6 plus 2 and minus 6 minus 2. Okay. We have one more pair, which is this mod y plus 4. The second number is equal to 12. So mod y will be 8, y will be plus minus 8. And if this is 12, this is 1. So mod x minus 4 should be equal to 1. Mod x will be 5, x will be plus minus 5. So plus minus 5, plus minus 5, plus minus 8. Okay. So 4 solutions here, 4, 4, 8, 8 to 10, total 10 ordered pair of solutions will be the answer to this particular question. But see, they were also saying distinct. Have we counted that? Are these all distinct? Yes, they are distinct. Are these all distinct? Plus 5, 8, minus 8, okay, yes, plus 7, 0, minus 7, 0. They all are distinct, there will be 10 solutions, okay. I hope this question is clear. Let's try this question. If this product, okay, is greater than equal to 2, less than equal to 5, both x comma y are negative integers, find the possible combinations of x comma y, okay. Now in the previous question we were having mod y plus something, right? Here this is mod y plus 3. So we don't have any control on the values of x and y, okay. So I'm very sure that this y plus 3, I mean it can have any value, right? This can be 0 as well, because y is minus 3, this will become 0. So it can be 0, right? So y can have any value, positive, negative, okay. This y plus 3 can have any value, but because it has clearly said that x and y are negative integers, x and y are negative integers, what can you say about mod x minus 1 if x and y are negative? Negative integers, what is the first negative integer? That is x equal to minus 1. If x is equal to minus 1, first negative integer, what is the minimum value of this mod x minus 1? It will be mod of minus 2, that will be 2. So 100% we are very sure that the minimum value of this is going to be 2, okay, minimum value is 2, so it can have value 2, okay, 2. What is the second value possible for this? Next negative integer that we have, it is minus 2, so minus 2 minus 1 mod of minus 3, that will be 3. If x is minus 3, this is 4. If x is minus 4, this is 5. You cannot take x beyond minus 4. If you take it to minus 5, then we are going to have minus 5 minus 1, that is 6. 6 into something will never be between 2 and 5, okay. I hope that is clear, okay. So 2, 3, 4, 5 are the only possible values of this mod x minus 1. Now let's talk about the other part, okay. We want the product to be between 2 and 5. So if this is 2, we can have 2 into 1, or we can also have 2 into 2, right? Because if this is 1, so we will have 2 into 1, which is 2, and if this is 2, so 2 into 2, that means 4. For 3, we can have 3 into 1 only, we cannot have 3 into 2, because 3 into 2, this is 3, this is 2, 3 into 2, 6, 6 is not between 2 and 5. For 4 also we will have 4 into 1, 5 also we will have 5 into 1. Now once you have these values, what you want to do is, this first one is going to become mod of x minus 1, while the other one is going to become mod of y plus 3, okay. So if mod of x minus 1 is 2, so let me just solve this one, okay. Mod of x minus 1 is 2, so x minus 1 will be plus 2, or x minus 1 will be minus 2. So that means x will be 3 or x will be minus 1. We will not accept x equal to 3 because we wanted negative integer values, okay. Both negative, x and y both should be negative. So we will only take x equal to minus 1 here. So let me just write down, say I'll make a table, okay. When say x is minus 1, what are the corresponding values of y you can get? You have mod of y plus 3 simultaneously, okay. When this is 2, these are the values of x I am getting, minus 1. if mod of y plus 3 is equal to 1, so then y plus 3 is going to be plus 1 or minus 1. So y is going to be minus 2 or minus 4. Okay, so there are two negative values of 5 which are coming over here, minus 2 and minus 4. How many negative pairs will be formed? Minus 1, minus 2, minus 1, minus 4. So there are two pairs that I am getting from first solution. Okay, this is when I dealt with 2 into 1. I hope this is clear. Okay, now let me deal with another pair 2 into 2. I hope you can do it now. Find out the value of x. Put mod x minus 1 equal to 2, you will get one value of x. Only take the negative value, put it here, and then mod y plus 3 will be equal to 2. So mod y plus 3 will be plus 2 minus 2. Okay, so again for y I'll get both negative values, minus 1 and minus 5, isn't it? So there will be one negative value here, something. Okay, minus 1 into this, minus 1 and minus 5 into this. Two values from here, two negative values from two pairs from here. So definitely what I am going to get is two negative pairs, two negative pairs, two negative pairs, two negative pairs, two negative pairs. Approx answer will be 10. Okay, you can check it out. Okay, you can just check the values here. This is a calculative question anyway. Okay, now this is your homework, this is your homework. Okay, this is your homework, this is your homework, this is your homework, this is your homework, this is your homework. Take couple of questions for homework. Okay, these are your homework. You can pause and solve them, and we'll meet tomorrow. Okay, so that's it with today's session. I hope you enjoyed it. You are liking the variety of questions, and I'm very hopeful that some part of the questions can come in the exam as well. And if you have any doubts, let me know. Subscribe to the channel. Okay, and for all the live marathons that we are going to conduct ahead, you will get a notification. I wish you all the best. In these days, I think these last few days, you should just revise formulas and all. Okay, you can maximum sit for a mock every day. Okay, and after you write your mock, you can just analyze it, whatever questions you are unable to do. Okay, why you are unable to do. If you see any new thing over there, new way to solve for a new variety of question that you have already done. Suppose you solve a modulus question and a new variety comes up. So keep that in mind. Okay. And along with mock, you are having your practice. To that you can add this 250 series, and there's another, if you go to the playlist section of this channel, there's a series called Quant 120 questions. Okay, there are very crisp 2 to 2 minute video solutions in that particular playlist. There are 120 questions approx, very good quality questions of arithmetic, algebra, numbers, okay, geometry as well. So you can go through that series as well. You will get to know a lot of things. Okay, do not exhaust yourself a lot. Okay, and take care of your health. These days there's excessive heat in Delhi NCR. Okay, in fact entire India. Don't fall sick. Okay, have good amount of water every day, because if you fall sick during this this week, then there can be a lot of problems on the exam day. Okay, you don't need that. Fine, thank you so much. We'll meet again.